Saxon Algebra 1, Lesson 1. Oh my gosh, here we are at the beginning of all things, you guys. Ready to start this amazing year. Lesson 1 is pretty simple. It's lots of review. It's not a ton of content, but it should feel very basic to you and maybe even annoyingly easy. Just remember that that's what we're doing here. We're building a house and we got to make sure that we dig down deep and get a really strong foundation laid. So we are going down to some really strong bedrock, hopefully, in your brain and tackling something that feels really good. And so we're going to start by talking about adding and subtracting fractions. I know, we spent most of last year talking about that, so what the heck. But that's okay, we can do it. I'm going to just buzz through some quick, they're not even examples, but just talking about that. Okay, what if we have a problem that looks like this? Okay, I see the 11s on the bottom. That makes me a little uneasy because 11's not a particularly friendly number, but they match. The denominators match, and that is the key to adding and subtracting fractions, right? The booties have to match. So once they match, I go, oh, well, this is easy. I just add the numerators and bring along the denominators. Okay, what if they don't match? Okay, there's two that don't match. Now, what I like to do is write these in a different format. I like to write them like this. Okay, so I'm just gonna scratch that out. And I can see the denominators don't match. That's why I rewrote them this way. It's because I wanna adjust them and I wanna have space. We have to make the denominators match. So the first thing we do is we figure out what's the least common denominator of these two. Well, 3 doesn't go into 5, 5 doesn't go into 3. So it looks to me like 15 is going to be the best we can hope for. So we're going to have to multiply each of these by a fraction that's equal to 1. I'm just leaving this weird space in here because of that scribble. And I want them to end up with denominators of 15, right? So 3 has to be multiplied by 5 to get 15. If I multiply 5 on the bottom, then I have to multiply 5 on the top. 1 times 5 is 5. 2, let's see, the second one, 5 into 15, that's 3 times. If I do 3 on the bottom, I have to do 3 on the top. So that becomes 6. And then now they have matching denominators, and I can actually add them, and I get 11 out of 15 as my final answer. All right, is this coming back to you slightly? We can do a subtraction problem in much the same way. Let's do 2 over 3, and this time I'm not even gonna copy it down in this format. I'm just gonna go right to my vertical. 2/3 minus 1 over 8. Okay. Denominators don't match. I'm gonna have to adjust. 3 doesn't go into 8. 8 doesn't go into 3. So it looks like 24 is gonna be my least common multiple or least common denominator, either one of those expressions. Last time I called it a denominator. Usually I called it a least common multiple because it reminds me that I can multiply these to get the answer. So, just like before, only with less weird wasted space. I'm going to multiply each of these by a fraction equal to 1, because when we multiply by 1, we don't change the value of anything. And in the end, I want to have 24 for both denominators. 3 times 8 equals 24. So if I do 8 on the bottom, I do 8 on the top. 2 times 8, 16. Pausing to let you catch up. Do the same down here. 8 times 3 equals 24. 3 on the bottom, 3 on the top. 1 times 3 is 3. These guys are adjusted. I take a quick look back and go, oh right, I'm subtracting. That's important. Denominators match, so we're golden. 16 minus 3 is 13 out of 24. I wrote that crooked just so I could squeeze it in. All right. So there's a quickie review on adding and subtracting fractions that are less than 1. Flipping. Couple different options here. This time we have mixed numbers. We have fractions, but we also have whole numbers that we have to add together. Excuse me. Now, here's the good news. We can just ignore these, right? And sometimes I even put a dotted line here to remind me that these guys are just minding their own business, and we're going to do these. We find the least common multiple. 5 does not go into 8, and 8 does not go into 5, so I multiply them together to get 40 as the first place where both of those numbers will fit. We're going to multiply by a fraction equal to 1, and we want to end up with 40 on the bottom for both. 5 times 8 equals 40, right? So I have to do 8 on the top. 8 times 3 is 24. And down here, 8 times 5 gives me the 40. So then I need to do 5 on the top, and that's just a 1 times 5. It's 5. Pausing to let you catch up. And, excuse me, yawning. Not bored, just yawning. We add these together and we get 29 out of 40. That cannot be reduced. But we also have 13 plus 2 over there. So our final answer is 15. And 29/40. That's a perfectly fine way to leave the answer. Even though it's kind of spread out, that's fine. You don't have to rewrite it. What about a subtraction? John has us use the very same numbers, but this time we're going to subtract them. They're mixed numbers again, so we're just going to separate the whole numbers and let them mind their own business. These are the same fractions we did, so I'm just going to use my answers. There's no reason to recalculate the very same problem. But this time we're subtracting, so 24 minus 5 is 19 over 40. Right? Do you guys see what I did? I just skipped this step because I'd already done it. So I just know that these two fractions are going to adjust to those two. So I just copied them. But instead of adding them, I subtracted 24 minus 5. That's 19. And then this is 13 minus 2, so that's 11. Right answer. And here's another little bitty curveball. Different numbers this time. 13 3/5, well, kind of different, minus 2 7/8. Okay, so let's see what happens that makes this one different. 5 and 8 will still use our least common multiple of 40. Right, because we have the same denominators. There's the boxes where my multipliers will go. 5 times 8 is 40. So it's got to be an 8 on the top. 3 times 8 is 24. I'm going kind of fast on this. I'm assuming that you remember or are beginning to remember how we adjust fractions. If this is too fast, slow me down, send me a message, tell me, wait, do that slower. 8 times 5 equals this 40, 5 on the top, 7 times 5 is 35, okay? Now we're subtracting. So now that the denominators match, we go over here and go, okay, 24 minus 35. Well, shoot and shuckins, we can't subtract that. That's a negative number and we're not gonna do that. So here's what we have to do. We have to borrow. We have to go back over here to our whole numbers and we say we're gonna take 1 away from this. We're gonna make this 12. And we're gonna take that 1 that we just subtracted there and we're gonna bring it over here and we're gonna add it in the form of a fraction, right? We subtracted 1 here and we're adding 1 here, but we're not adding it as 1, we're adding it as 40 over 40, which is the same as 1, but we want it in this shape so that we can combine the denominators. Now we've got 64 over 40, and now we can subtract 35 from it. Remember that in all of our work with John Saxon, unless I give you extremely explicit instructions, no calculators. Ever, 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 ever do we use calculators. We use our brains. We keep them exercised well. We do not become mental couch potatoes. So we're subtracting, so we're gonna go 64 minus 35. Some people feel like they need to do little calculations like this on a piece of scrap paper or scratch paper, or they need to erase them. No, this is part of your work. Leave it right there. Just do it off to the side a little bit. Sometimes students who are super into keeping things neat like to put a little box around them. So it's kind of like a little separate section. If you want to, that's fine. I don't usually do that. I just write it to the side. Okay, 4 minus 5, no can do. Borrow. 14 minus 5 is 9. 5 minus 3 is 2. So this becomes 29 over 40. And now we can do 12 minus 2, that's 10. So our final answer is 10, 29/40. So this can't be reduced. None of our denominators have been reducible. All right, so this is subtraction with borrowing. Fun spin. All right, flipping. Example 1.1, our first example of the year. Let's just take a moment and celebrate what a momentous event this is. And John tells us to add, and I'm gonna write it the wrong way because, you know, sometimes that's fun. This is the way he did it in the book. Okay, I don't like it because there's mismatched denominators and we really don't have room to properly adjust them. If you are super neat and super, super comfortable with this process, you can kind of make little notes in here and do it the quick and dirty way. But I don't like to do it that way, and I don't like to see you do it that way. What I much prefer is don't even copy it down like this. Don't be like me, kids. But just immediately adjust it to this format. Okay, so we're subtracting that and we're adding that. That's really confusing. All right, so this problem A looks more confusing and B is going to require a slightly more complicated process. Oh, excuse me. But it's really not more complicated, it's just kind of fussier. So we have to find the least common multiple of 11 and 6 and 3. Now, I notice right away 3 goes into 6. So I don't really have to worry about the 3 separately. If I just make the 6 happy, then the 3 will go into it as well, right? Because we're trying to find that number that 3 and 6 and 11 will go into. This is for the least common multiple of 3, 6, and 11. 3 goes into 6, so I can ignore it, kind of. And so I'm going to guess that our least common multiple should be 66, right? Because 11 goes into that, and 6 goes into that, and then 3 goes into it as well. All right, so we're going to multiply each one of our fractions by a fraction equal to 1. And we're going to end up with 66 on all of our denominators. That's our goal, right? So I go up here, start at the top. In order to multiply 11 into 66, I need to multiply by 6. Top and bottom have to be the same because this has to be equal to 1. 10 times 6 is 60. Second one, 6, see, I told you the answer. I have a really bad habit of that. 6 times 11 equals 66. So 11 is the number, top and bottom, and that becomes 55. 3 into 66 is 22 times. If you needed to do a little long division to help you remember that, 3 into 6 is 2. Could have done it that way too, right? Again, this is not something you should erase or be ashamed of. This is a side calculation that was important. So just leave it to the side. 22 on the top. 1 times 22 is 22. All right. Whew. Matching denominators. So that's great. So we can do 60 minus 55 gives us 5, and then we're adding 22. So our final answer is 27 over 66, but as I write that down, I go, oh, here, it should be down here, sorry. My brain sees that 3 goes into both of these numbers, so we can reduce it. So we'll divide it. You can do this mentally, but I like to write it out so you can see what my brain is doing. 3 goes into both of these numbers, so 27 divided by 3 is 9, and this divided by 3, we just figured out, is 22. There are no whole numbers in this, so this is our final answer. And I just glanced at the book. John agrees. Yay! Yay, 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 yay. All right. We're not done, but that's the vast majority of this lesson. Part B is about lines and segments. A little bit of geometry to go with our mathematics refresh. You know that there's such a thing as a line that goes on infinitely in either direction, but we can identify points on a line and talk about the chunks of the line in between them as segments. So lines are infinite, but segments are finite. It always seemed like this word should be pronounced infinite, right? So because it's infinite and finite, it doesn't sound the same. That always bothered me. All right, so we can talk about segment AX, which is how we'd write that. That would be this bit. We can talk about segment AC, which is the whole chunk. We can talk about segment XC, which would be that bit. And then we can reverse the letters too, but that's kind of confusing, so we don't usually do that. The way that the problems involving this information are going to look, I'm going to flip the page. Look like this. You get a picture. And it's not a full line, it's segments. It's just a segment of a line with an A, B, and a C. And we're told that segment AC measures 10 1/4 units. We can pretend it's inches, miles, whatever. And segment AB measures 4 3/7. and it asks us to find BC. Okay, I'm just writing all that down without trying to make any sense of it, so that I get all the information on my page where I can look at it and puzzle it out. Let's go back. A to C, what is that? Oh, that's the whole big thing. That's like this. And we're told that's 10 1/4 units. AB is 4 3/7. And we're supposed to find BC. So I'm gonna make that squiggly because we don't know that. All right? So I hope what you can see is that we've got ourselves a perfect scenario for subtraction, don't we? We've got the total and we've got one component and we need the other component. So our approach is going to be to take 10 1/4 and subtract 4 3/7. Hard to say. Dotted line to keep my whole numbers separate. Least common multiple. 28, which I deduced because 4 does not go into 7, 7 does not go into 4. They don't have any factors in common, so we can just multiply to get our least common multiple. We're going to multiply it by a fraction equal to 1, so we don't change it. We know we want to end up with 28 in our denominators. 4 times 7 is 28. So 7 is our magic number. 1 times 7 is 7. 7 times 4. So we're multiplying by 4 down below, and that's 12. Right? Okay, good. We've got matching denominators now. We're ready to subtract 7 minus 12. Oh my gosh. All right, one more step. We have to borrow, right? Because this number is smaller. So we're going to take 1 away from that number, and we're going to add 1 in the form of a fraction with a matching denominator over there. Let's put the LCM in a puffy cloud of knowledge so it doesn't intrude on our work here. Now we have to add those. 7 plus 28 is 35 over 28. Now we can subtract 35 minus 12. Here, I'll do that here in case you can't do it in your head. 5 minus 2 is 3. 3 minus 1 is 2. So our answer is 23 out of 28. And now we have 9 minus 4 is 5. And because we're told that the units are, it's called units, we can write, if we want to be super precise, whenever we're doing any sort of problem that has dimensions given to us, we want to use those dimensions in our answer. This one is kind of borderline, but I went ahead and put it in. All right, so that is our first lesson. What I want you to do for your homework is we're going to stretch this one lesson out for 2 days of homework. Okay, so this is probably, I'm hoping this will be Monday and this will be Tuesday, if your schedule looks like mine. So, the first homework I want you to do is lesson 1, the odds. And then for your second set of homework, hopefully tomorrow, it'll be lesson 1, the evens. Okay? So we're stretching one teaching lesson over 2 days of homework. In this first lesson, there is no practice. Okay? It's problem set only. In the future, we'll be doing practices, and I'll talk about that next time when we get to that. But that will be days 3 and 4. And let me just show you how it's going to look so you see the whole thing at once. It's a little confusing these first couple weeks, but we'll straighten it out. on day 3 this week, which let's just say you're going to do it on Wednesday and Thursday. Okay, so on Wednesday I'll send you lesson 2, and you'll get 2 days of homework out of that as well. You'll do the odds and the evens. Okay, so we're kind of baby stepping our way through this first week by taking one lesson and doing 2 sets of homework out of each lesson to help give you a little bit more time to get your brain in gear and up to cruising altitude. Okay, so you're ready to do these 2 now, and I will see you again on Wednesday to talk about lesson 2. Thank you. Goodbye, students.